Okay, so let's have a look at our first assignment. Today's video is going to be looking at the first two parts, so how we can achieve high grades on part 1 and part 2. The first bit about displaying the data to compare the heart rates before, during and after the multi-stage fitness test looks at your ability to develop your own graph, your own table to show certain things. Okay, I've produced this table with the data, with the information on there, but what can you do with this information to expand on it? So how can you display it differently so it's a bit easier to see in a visual representation? So maybe utilizing this to draw a graph. Okay, there are 3 key points. We've got the resting heart rate, the heart rate that they achieve when they finish it, and the heart rate that they achieve at the end of the recovery. They're 3 major points to us. To achieve that C grade, we're going to do some sort of graph that helps us analyse those 3 things: resting heart rate, what it was when they finished the B test, and what it was at the end of the recovery. To get up to those B and A grades, though, we're going to utilise all this stuff that's in the middle, so we can see clearly what's happening with those heart rates throughout the test and throughout the recovery. So think about the way that you display this information, whether it be in a table like this and add a couple of things on, or whether it be in some graphs with them 3 key points, or if you're aiming for those higher grades, which I think you should be, you need to be utilising this information. You don't have to put it on one graph, you can put it on multiple graphs. It's entirely up to you. It's just the question just says display the data so that you can compare them. The second part of number 1 is indicating the anaerobic thresholds and predicted VO2 maxes. Predicted VO2 maxes are pretty straightforward. We need to look at what a subject achieved on the beep test. So we're looking at their final score. So we'll look at Jane. She achieved 6.2. Now to find her predicted VO2 max, I go to these tables, find 6.2, so level 6, 2 shuttles, and look at this here. So that's her predicted VO2 max, so 33.6. The next table looks at how they compare. So Jane got 33.6, so she's kind of in this bracket here, so Jane's below average with regards to her VO2 max. So just understanding what VO2 max is this, maximum oxygen uptake, okay, and that's per minute, something that we'll talk about later. And that's how we can compare the predicted VO2 max. The hard bit though is this anaerobic threshold. So how do we calculate this anaerobic threshold? And that comes into this part 2. So we're going to start off by defining what anaerobic threshold is. So I would utilise a website called Brian Mack, which is quite a useful website, so I'll put that down that way. What's going on here? Sorry. For definitions, I would look at things like Brian Mack. So www.brianmack.demon.co.uk. And that can be a really useful website for a lot of the definitions and things that you might get stuck of later on in this. Okay, that's pretty useful though. So how do we calculate this VO2 max? That's done by knowing 2 different things. The first one is your maximum heart rate. So understanding what the maximum of times your heart can beat in a minute. And that changes with age. So we calculate that. A real rough estimate is 220 take away your age. And that equals your max heart rate. So for these people that took part in this test, they're all 18. So if we calculate that, we do 220 take away 18 equals 202. Okay, so every person who's done this test has a predicted max heart rate of 202. We utilise this 202 now to work out this anaerobic threshold. So part of the definition that you'll have had is that anaerobic threshold is about 80% of your max heart rate. Okay, so I'll just make a note of that. Anaerobic threshold equals 80% of max heart. Okay, so to calculate it, how do we actually work that out? We need to know what the max heart rate is, and that's 202, and we need to know what 80% of that is. Okay, so 80% of 202. So how do we actually do that? 202 multiplied by 0.8. And that equals 161.6. Okay, so about 161, 162 beats per minute, and that tells us what our anaerobic threshold is. Because of all the athletes are the same age, they all have the same anaerobic threshold. Now you need to go back to part 1 and display this within your graph or your table, or however you chose to work this data, and show on this anaerobic threshold here. You can have a look at max heart rate as well, so do any athletes reach their max heart rate. Do some go over it, which you'll probably find that they do, because that's just a guide, or just a pretty rough guide. Okay, so that's how we're going to work through part 1 and part 2. Do athletes reach these points, and how can they train it? So that's the second bit. So how can they train to improve this anaerobic threshold? We've got to think about methods of training, and also the principles of training. So how can they alter them 4 key things of frequency, intensity, time, and type in order to change an athlete's ability to not produce as much of this. So we'll talk about some long-term effects of training in our lesson on Friday, which are going to help with this. Hope that helps, and if you've got any questions, then just make a comment and I'll try and answer in the next video, or just catch me in class and I'll go through them. Remember, don't forget to subscribe.